Good morning, everyone. So this is the second session for many of us this morning. It's about ensuring continuity of emergency communications. I believe a very, very important topic with all of the, let's say, external effects that we see happening in the real world out there. Let it be man-made disasters, let it be nature disasters, let it be just technical outages. And so the topic of continuity really is important for guaranteeing access for the citizens to the 112 and other emergency services. So within this session, we have three groups of presenters. We have April Heinze from the National Emergency Number Association from the United States, talking about continuity of operations planning for emergency communications. April, welcome. Secondly, then we have Bogdan Belciu and Alexandru Vadana from the Romanian Specialist Telecommunications Service, presenting ensuring continuity of emergency communications from a technical and operational point of view. Welcome, Bogdan and Alexandru. And last but not least, we have Jörg Rieder from Atos from Germany, and Jörg is going to present call handling as a service, a cloud-based topic probably, so I would be quite excited to listen to this as well, Jörg. Right, so introductions done. Stage is yours, April, please go ahead.
Good morning, everyone. So I'm here to talk on the operational side of things. We're going to discuss first what NENA is. NENA is the 911 Association. We're a standard-setting organization. We do policy, advocacy, and education for 911 throughout North America and the rest of the world. NENA, we have just over 18,000 members. We set technical and operational standards that govern 911 and NG 911 systems. And we are the only standards-based organization that is completely dedicated to 911. In this session, we're going to talk about continuity of operations planning from an operational perspective. We're going to talk about the plan importance, why it's so important to have this plan, training and exercising, as well as resources and templates that can help you create your own if you do not have one. So next, first and foremost, what is a continuity of operations plan? Continuity of operations plan addresses an emergency from an all hazards approach. It ensures that you have policies and guidance for your staff to handle the critical functions and ensure that they continue throughout the entirety of the situation. Effective continuity of operations planning is the responsibility of the entire community, public safety community. So it's really important that you invite all aspects of that emergency communications plan, from communications all the way through all of the different responding agencies. And then you also want to really identify outside entities that may also be a part of your continuity of operations plan. Yesterday morning, Eric McNulty, our leadership speaker, talked about leading effectively, meaning you need to communicate with everybody in the public safety realm. So how do you start that? Well, I'm going to tell you how you start that conversation. You bring in, as he mentioned yesterday, you get those your favorite pastries and coffee, and you invite those folks in, and this is how you start those conversations. You ask for their input to ensure that the plan covers every aspect that you are trying to cover. So there are 11 major elements of a continuity of operations plan. The first element is essential functions, and the essential functions are a limited set of functions that will allow your organization to continue to operate throughout the entirety of the event and rapidly resume normal operations as the event scales down. Orders of succession are provisions that enable an orderly and predefined transition of organizational leadership positions. If your organizational leader is somehow either incapacitated or otherwise unavailable throughout that process. Then you have delegations of authority, and delegations of authority help you to identify by position the authorities that can make policy decisions and determine from the headquarters all the way down to the field level. You also have continuity facilities, and these are locations which your leadership as well as critical positions will operate from. This also allows you to identify facilities or virtual offices which you can continue essential operations from as well. You also have continuity communications. And continuity communications are systems to fully support connectivity among your leadership, internal elements, as well as organizations to perform essential functions during your emergency. We have essential records management, and this is really key because you need to be able to identify, protect, and have available information systems that include electronic and hard copy documentation of your references and records that you need to support your functions throughout the entirety of the event. Then the most important piece to me is your human resources. And you need to have your policies and procedures predefined, as well as address the human aspects during that emergency. That includes, how do you pay your people? Leave, do you need to have leave time established? Scheduling, benefits, telework opportunities, hiring, and the list goes on and on. And then here's another very essential piece, and that is you being able to test, train, and exercise on this plan. Training is making sure that your personnel are prepared to handle this event before it happens. And then you do the testing and the exercising to ensure that you have all of the critical functions covered and you're validating your plan throughout. Then there's the devolution of control and direction. And that's your capacity to transfer statutory authority and responsibility of your essential functions for primary operating staff and facilities to other places in the event that you have to evacuate or relocate your operations. And then you've got your reconstruction operations, right? And that's your organization's ability to resume normal functions at the end of the event. And then last but not least is the program plans and procedures. And that's the effort to document the existence of this plan and seek the capability to continue the organization's essential functions during any wide range of disaster situations. So pre-planning it enhances your ability to respond and mitigate any disaster. It allows your organization to set in place processes and procedures to follow when the unthinkable strikes. So continuity planning is simply a good business practice. It ensures the execution of essential functions through emergencies. Without the planning and provisioning and implementation of continuity principles, first responders may not be able to provide the necessary services to help their citizens when they most need it. So, why is training important? When emergencies strike, it's absolutely imperative that you know your job and your resources so well that you don't have to think about it. You can react based on muscle memory, And if you don't do this, if you do not train and your staff is not familiar with your continuity plans, you are actually placing them at a disadvantage. Repetitive reinforcement by reviewing your training concepts to reinforce memory retention is essential. People forget 90% of what they learn within 30 days of that message being delivered if it is not repeatedly reinforced. So, train, and train some more. Incorporate your continuity operations plans in your annual refresher trainings for your emergency communications centers. Emergency communications centers should institute training and policy procedures that provide a framework for your staff to remain current with your contingency plans. The training should include be included in initial onboarding and ongoing training throughout your employees' life cycle. Exercising your plan is essential. Exercising is the most effective means of ensuring your plan is effective. Types of exercising and tests that you can use, I guess I should probably move to the next slide, are your tabletop exercises, full-scale exercises. A lot of times your emergency managers do full-scale exercises to train or to test their plans. Well, that is a great time to test your continuity of operations plan. Pull that plan out and make sure that it will work during those full-scale events. You can do tabletop exercises internally to ensure that your continuity of operations plans will work as well. And then you want to do after-action reports and improvement plans to ensure the validity of your plan and update it if something is needed to be updated. So NENA has some resources that you can use to help you with your continuity of operations planning. So we have our Communications Center, PSAP Disaster and Contingency Plans Model Recommendations. The website is up there on the screen. The purpose of that document is to serve as a reference for contingency planning in your standard operating procedures. The document includes best practices and guidelines for procedures on staffing, IT security, redundant systems, situations requiring evacuation procedures, returning to normal operations, and so on. And then we also have the PSAP Survivability Information Document. Again, the website is there on the screen. The document is intended to be a guide for emergency communications staff to review the many different components within their own systems and continuity disaster plans. It's also intended to guide for training, testing, and reevaluation of your ability to react in that disaster situation. And then another set of resources that you have available to you is through the Cyber and Information Security Agency of the U.S. government. Emergency Services Sector Continuity Planning Suite. They have this suite of guides that and tools that will help you not only create your continuity of operations plan, but validate your continuity of operations plan by exercising. And there are a multitude of different guides out there so that you can create your own exercises, both tabletop and full scale. All right, do you have any questions?
Thank you, April. So opening up for questions. We have a little bit of time for maybe 2 questions.
I covered it so well, nobody has any questions.
So I don't currently see a question.
That's good.
So maybe I can have a question to you, April, yeah? So you as NENA are providing a lot of resources on this kind of topic. Have you been talking with your field, so with your PSAPs, how they took these resources and how they implemented it and what their feedback is on these resources?
Sure. So we have as a standard-setting body, we have committees that actually work through all of these different topics. So they're created by the people who are actually going to use them. So as we update these guides, they are available to anybody to comment and provide additional feedback. So far, my own PSAP, when I was in a PSAP, we used these guides to create our own documents. And quite frankly, they work. They're very, very important to have.
Thank you. So there's still time for questions. Before I would like to hand over, let's see if there's someone raising the hand. And if you raise your hand, please raise it vividly. Otherwise, it will be difficult for me to see. Right. So I think we are good to go. Thank you very much, April, for this insight. Next on stage, then I would like to welcome Bogdan and Alexandru from the Romanian Special Telecommunications Services, sharing their insights with us.
Thank you. As the chairman said, my name is Alexandru Vadana. I'm the Bucharest PSAP coordinator, and my colleague Bogdan Belciu, a network engineer. Today, we will talk a bit about the operational approach in the present, the technical approach in the present, and the NG112 system, and the operational approach with the NG112 system. But before we start, I would like to say that in the 2021, the operators, the 112 operators in Romania answered over 10 million calls to 112, which means that basically every 3 seconds someone called the 112 emergency system. So we know that the 112 emergency service ensures the contact between the citizens and the authorities by collecting the specific information from the people that call the 112 emergency number and then transferring them to the emergency agencies in order to ensure an immediate and uniform reaction for the emergency settlement, helping people in critical situations and in many cases saving their lives. In Romania, we have 41 PSAPs. Basically, each county has one PSAP, and the Bucharest and the Ilfov County region has only one PSAP. All of them ensure that the 112 calls are processed 24/7, and at the moment, the number of 112 operators ensure that all the calls are being taken operatively in normal conditions. But we are aware that there's a continuous increase in the complexity and the variety of the situations that require the intervention of specialized emergency agencies. Basically, more and more often during the summer, there have been reported tornadoes, storms with powerful winds that cause great destruction, and torrential rain that cause floods in inhabited areas. And when that happens, we are aware that the number of 112 calls increases rapidly. For example, during a storm in 2017 in Timiș County, there were up to 70 calls per minute for about 30 minutes continuously, totaling no less than 4,700 calls per hour, compared with almost 100 calls per hour in normal conditions. Also, in Bucharest, in January 2019, a freezing rain paralyzed the capital. Almost 9,000 calls per hour were received, and almost 33,000 during the day at Bucharest PSAP only. By comparison, in normal conditions, we have somewhere between 5,000 and 10,000 calls per hour. Also, the pandemic had periods with a great number of 112 calls. We had up to 2,500 calls in 1 hour and almost 20,000 calls in 24 hours at Bucharest PSAP. But the greatest difference between the pandemic and the major local event was the period of time in which it manifested. So, when these things happen, the 112 emergency system must be resilient and we must take action. For that, we have a 5-steps plan with the current system. Basically, when a major event takes place in one county, for example, the operators from that respective county will continue to take the calls from the call queue, and the operators from other counties will use an application that shows the unanswered calls, which was specifically developed for such situations, and they will redial those numbers. Second, each PSAP has operational support consoles for other PSAPs, which will be used in order to increase the number of operators that can answer 112 calls for the affected PSAP. Also, depending on the operational situation, additional operators can be brought from home in order to ensure that all the 112 call-taking consoles are used in the affected PSAP. After that, if the situation is lasting for a long time, like the COVID pandemic, the staff that once used to be a 112 operator in one of the PSAPs can and will be enrolled for call-taking process if still works in the institution. Also, we have 2 backup centers. Each one has about 10 call-taking consoles. They can be activated and become operational in a very short amount of time, and they can be a real support in a prolonged emergency context that takes place in one or more PSAPs. And of course, in some situations, referring also to the COVID pandemic, the retired personnel that once was the 112 operators has been reactivated and enrolled for the 112 call-taking process. And now I will let my colleague talk about the technical approach.
Thank you, Alex. Well, taken from a technical perspective, the 112 service in Romania was deployed over a traditional ATM backbone with 41 server rooms dispersed across the counties of the state of Romania. Initially, the system was a closed one with a small number of data entry points. Over time, this number increased, and due to the fact that we had to add so many features to the 112 system. Streamlining information such as advanced mobile location, e-call, or 112 mobile app calls represent a natural evolution regarding the cross-domain connectivity. But in order to provision these services to our old infrastructure, some workarounds had to be made. These workarounds tend to bypass our old security protocols and expose our infrastructure to a vast array of threats. We started to redesign our infrastructure. The keyword that we had in mind when redesigning it was resilience. When people's lives are at stake, there's no time for downtime. We started our approach by doubling every piece of hardware in the infrastructure. Then our team deployed stacked equipment, high availability clusters, and connected all this new infrastructure using resilient and redundant links based on over different transmission environments such as optical cable and broadband radio links. The communication between the 112 operator and the data center is transported across our MPLS infrastructure, which is built on highly resilient optical interfaces. In order to ensure the fast convergence of the routing tables in our new system, we use protocols such as bidirectional forward detection and fast reroute. Another key aspect that we followed in the new design was simplicity. The old implementation, the legacy one of the 112 infrastructure, was having 41 data rooms. It was a burden to administer such an infrastructure. And over time, this infrastructure had so many changes at a local level that there was no similar approach on all of them. Our new infrastructure is using 3 big data centers that are working in a high availability mode and can load balance the traffic in real time between them. Migrating from the old infrastructure to the new one came with lots of problems as well. While changing the entire infrastructure, we had to make sure that 112 operations are not affected. To achieve this goal, we extended the routing domain of the new infrastructure to the 112 application server from the legacy one. This way, the 112 operator had access to both systems till the new application stack will be fully operational. Also, during the migration of mission-critical locations, such as PSAP, we rerouted the 112 calls to be sure that none of them is lost. We rerouted them to some other location that has a small volume of active calls at that moment. From the cybersecurity perspective, our new infrastructure is ISO 27K compliant. We choose to remove our traditional routers from the network and implemented at every 112 agency a firewall cluster, which allow us to properly filter our traffic. Also, we implemented a microsegmentation framework into the data center network in order to contain any potential threat that could come up in our system. Moreover, we identified all our internet connections and applied an entire security fabric on them in order to ensure a better security. Our security fabric consists of next generation firewall, intrusion prevention system, antivirus scanning, and DNS filtering. All of these features combined are monitored in our new infrastructure, our new monitoring security infrastructure, where our SOC engineers can intervene in case of a security incident. Expanding the visibility across the entire platform came as a must for our infrastructure with the needs for resiliency and new security. But having such a large infrastructure with so many equipments configured in a redundant way bring a lot of information. However, we have to filter it. We came up with a hierarchical model in order to isolate the root cause of the events and help the NOC team to discover the incident and have a response to it. Automating the workflow came really handy. We automated, scripted, we use lots of Python code to eliminate the repetitive task from the NOC team. It helped a lot. It is helping on reducing the time for remediation and isolating the important alerts from their NMS. Also, having a modular approach helped us scaling horizontally and also helped us to have a fast provisioning in a matter of seconds of new services across the new infrastructure. Moving forward, there is a lot of things to be done. We have lots of things to learn, but we are looking in extending our ways to the end user. We want to integrate in our new platforms new means of gathering a more automatic way of information regarding the person who is actually calling to the 112. Also, we are exploring the introduction of the AI operation in our technical support process. We find out that it would be very useful to us to tend to self-healing infrastructure. Over time, this could be a lot of help for us to manage a huge infrastructure and maintain our entire security posture as well. Alex?
Okay, thank you. So going back to the operational picture, referring to the next generation 112 system that is currently being implemented, I can say that one of the greatest benefits is the ability to take the calls at local, regional, and national level gradually. This means that any operator from any PSAP will be able to take a 112 call that is made from any other region of the country. And suddenly 2,500 calls per hour will not be such a great burden anymore. How does this work? So, supposedly, at first, the 112 call is presented in the call queue at a local county level, but let's suppose that because of a major local event, the operators cannot take it. So it will be automatically transferred to a regional level, but there are situations that where the operators at the regional level cannot take every call because the phenomena affects a wider area. So, if that happens, the call will be presented at a national level where every operator from the country can answer it. Another feature, important one, is that the operators will be able to transfer the call to the emergency agencies of the country from which the caller reports the incident, and even more, because every second counts. Many of the actions that the operator had to do manually until now, from now on, they will be done automatically. As a conclusion, we can say that ensuring the continuity of the 112 system is a complex process. Some of the steps that have been taken until now will be taken with the NG112 system, but that will be done in order to achieve a greater resilience of the system. But the time required for processing a 112 call will decrease, while the capability of receiving a great number of 112 calls will increase.
We truly believe that that our approach on the next generation 112 platform will be a success and will be able to fulfill the further needs of expanding our capabilities in ensuring the next generation services for mission critical development.
Thank you.
Thank you, Bogdan and Alexandru. You made it just within the last second on time. Thank you so much. Well done. We do have a break after this one. So if there is one question, I could admit one question. If you want to really wave your hand, if you have a question to Bogdan or Alexandru. This does not seem to be the case. So thank you again, Bogdan Alexandru. Very impressive presentation, and I would like to hand over to Jörg now.
Yeah, thank you, Markus. Hello, everybody. I'm Jörg Rieder, as introduced. I'm from the public safety team of Atos, and I like to talk today on how call handling as a service can ensure continuity in emergency communications. So what we're going to look at today is basically call handling as a service architecture, call handling as a service cloud principles, so what is going to come with it, and also benefits of call handling as a service. So before we get into the details, when we look at emergency communications, there are a lot of things which can also go wrong. And this can be things, when I think about it, like infrastructure is failing, we have hardware servers which are failing, there can be software bugs as well. I mean, everybody knows software is never 100% error-free. And there can be cyber attacks, as more as we get into the IP world with all the solutions, this is quite possible. And also, there can be needs of flexibility triggered by disasters occurring, what we heard from the colleagues, where there is a need of getting more call taker very quickly into either call taking centers, or when we look at call handling as a service, probably in the future doing it also from home or any other location where they are. And when we see what a pandemic can do in terms of people in the office, in a PSAP center, to also ensure that they have social distancing, we may send people to other centers to ensure this. Yeah? So there's quite a lot of things which can happen there. So now, what I want to look first at is comparing shortly what we traditionally have with a PSAP on-premise, and then every PSAP has his own server room, yeah? As we heard in Romania, 41, and it's quite cumbersome over time to keep them up to date, quite costly. And when we go and move into a call handling as a service, so next generation emergency calling as a service, everything stays the same in terms of there is the EasyNet NGCS delivering the call routing, but when it comes to the call handling, we are basically having the cloud, there is a service delivered, and the PSAP or the PSAP center, what is required there is obviously MPLS links, all kinds of things to connect to the cloud, but no server rooms anymore locally, or shrink down to a bare minimum of some base equipment, also for IP network within the PSAP and so on, and a workstation plus personal equipment for the call taker, and this is going to do the job communicating with the cloud service. Taking calls in audio, video, text, real-time text, this is all feasible already today, for example, using WebRTC to be fully browser-based. Before going into cloud or call taking as a service, let's look what PSAPs and the technical stuff of PSAPs have to worry about today. On the left, in red, I mean, it starts with there are data centers which need to be taken care of. There's network, storage, server hardware. The PSAP technical team need to look into that the servers are always up to date. Hardware needs to be exchanged. There's virtualization. Operating systems need to be patched, and a lot of more things. And then there's obviously security, which is very important, and the applications itself for the call taking and all the surrounding systems. Now moving this to next generation emergency calling as a service means that for most of this stuff, if not even all, this is managed by the provider who is providing such a service. which makes things easier. And I'm not saying that, for example, for security, the PSAP is just going to go and say, okay, provider, you do it. No, the PSAP obviously still needs to have control over how things are done, but doesn't need to take care of the operations of it. With call handling as a service, I see some principles which are there, which go from availability of a cloud service, which means cloud is providing availability of the resources in multiple zones, different regions. This paired with redundancy of the deployed applications is basically helping to avoid single points of failure, which is very important. Then there is the resilience in terms of monitoring the system, scaling it out as needed in peak hours. Security, which is going to be built in already in the cloud, having secure links, having identity management also built in the cloud, which makes it much easier to keep track of what is happening and to have the right people, the right resources accessing such a system. And also single sign-on with multi-factor authentication if security is built out in a standard way. Last thing, durability in terms of storage. Storage is, with all the data which are created in PSAPs and in an NGCS, always a big problem. In the cloud, you have unlimited resources, plus the cloud providers usually guarantee more than 5 nines of availability of such storage and also of the other systems. Besides these principles, we also have benefits which are going to come with such a cloud service. So to start with, elasticity is quite a good thing to help scale out the system automatically as it's required. When there is busy hour call attempts coming up and a high number of calls need to be processed, as we also learned from the Romania team, in some disasters occurring, is it flooding, is it anything else? This is quite helpful because it scales up automatically, nobody need to take care of, and if more resources needed than usually available, it's not a problem. Unlimited capacity. Today, when you're going to plan your data center for a PSAP backroom, you need to plan, okay, how much storage, how much memory, how much servers do I need to run my system, and to also do this for the peak hour of emergency calls you need to process. During normal operations, the system might be idle to some extent and is not used. In the cloud, obviously the cloud provider does planning, but you as a PSAP organization, you don't need to do this anymore because it's taken care of automatically. And it's going to also be less expensive, and where you also, when you do it in an own data center, you always need to look, what can I afford? What do I need? And maybe you need to have a compromise in terms of cost. With call handling as a service, this is going to be much easier. Managed infrastructure. So the complete solution, if you want, is going to be managed centrally. So this means the provider is going to take care of it, and the PSAP can concentrate on what matters most on the call handling of emergency calls and everything what's coming with it. Flexibility. I have talked a lot already about how flexible cloud can be with resources and so on, but I personally see also other needs in terms of flexibility, which is access to the PSAP solution from anywhere, wherever you are, at home, in another office, so that if required, people can jump on and take emergency calls as required in case of a disaster. And what is also important there, if the technology used is fully WebRTC based, this is basically going to promote, you only need a workstation with a browser which is WebRTC enabled, and you can start working together with a headset. So relatively easy, also doing this, for example, from home or somewhere else on the fly, as long as a network connection is available. CapEx versus OpEx. There's always the question, if you're going to move to a new system, okay, how much upfront invest needs to be done to allow moving to a new system? If you're going to do this with a cloud service, this is helping to minimize the upfront investments. So you don't need to create a new data center. You need to take still care of MPLS links and so on to connect, obviously, to your PSAP location, but the usual high cost for new data centers is going to be minimized. Speed and agility. So what is also important is that onboarding of new resources, updates, troubleshooting, that this can happen in a fast way, coordinated, secure, and using a cloud service, it is for the provider possible to always monitor the system, to automate onboarding and so on, so you have a very silent operation there. And if there are problems, troubleshooting can also be having the right tooling easier than in a very scattered environment. Next topic, enhanced security. Today, the PSAP organizations, the technical teams, are very much involved in how is the security basically working within the solutions. And then you need to do this for every PSAP you have, in the worst case scenario, depending how the hardware is deployed. When you move to call handling as a service, this is going to come built in, and the provider is going to take care of the security, which doesn't mean everybody should lay back in the chair and say, okay, everything is taken care of by the provider. I think it's always good to double check, to get security protocols, to see how incidents are managed and so on. Also, how the patching is done in terms of vulnerability process and so on from the provider. But you don't need to care about all the daily work to be done there, which can be quite extensive. Innovation. I think innovation, cloud is a huge opportunity to drive innovation into public safety, and I'm a strong believer in innovation is going to help moving public safety forward over the next years. Yeah? And cloud is going to help by providing new technology out of the box, like AI, like translation services, transcription services, using standard APIs. This can be leveraged in a very straightforward way, integrated with the applications, and with this making it available. Before we close, I want to take a short look down into the machine room, as I've called it here. What is usually going to be deployed in the call handling as a service? And when we start from the left to the right, so there is the EasyNet as it is today with the core services, so there's no change. It's going to be connected to the cloud service via, for example, MPLS links, and it's going to deliver the calls. In the cloud service itself, you have all the components in a redundant way, and you have a BCF. Similar, you can have it on-prem. You have a recorder, which is doing ZipRec to be fully standards-based. You have then a PSAP call engine, what is usually an IP soft switch. And then you have, if you have WebRTC, a media server gateway, which is doing translation between SIP and WebRTC to move basically voice, video, text, real-time text into the pure browser-based communication. And you have the call handling system providing the workflow, screens, and so on. And with this, the PSAP only requires a workstation with the browser, and this is basically going to do the job to be able to communicate with emergency calls. So to summarize, from my perspective, it is about stability, resilience, security, durability regarding the storage. And this comes integrated with call handling as a service. It is about innovation, this is key, leveraging what cloud is providing. And when you look at the big cloud providers outside in the market, this is also how they want to differentiate, by providing newest technology with latest innovation to help their customers moving things forward, and we can leverage this here also for public safety. And deployment and maintenance. What is key is that for the deployment and maintenance, there is automation getting part of the process to really leverage what cloud can do, what a cloud service can do. Yeah? So as much as automation is feasible and possible, this is going to help getting the full power on the street, so to say. And continuous monitoring is also going to help in the maintenance to basically predict problems and even go and solve them before they come up in the best case. And this is the last slide. I say thank you, and up for questions.
Thank you very much, Jörg.
Welcome.
So again, you're ahead of time, so we have one question maybe before I leave you to the break. Do I see any hands waving in the audience? Doesn't seem to be the case. So thank you very much.